So lastly, we are going to look at exercise 69 under section 7.2, and it says to prove that the integral from minus pi to pi of cos mx multiplied by cos nx dx is 0 if m is not equal to n, and pi if m equals n for positive integers m and n. So the first thing we're going to do is we are going to start with our integral. So we have the integral from minus pi to pi of cos of mx multiplied by cos of nx dx. We can write that as the integral from minus pi to pi of a half cos m minus n x plus cos of m plus n x dx. So where does this come from again? Just a quick recap. Well, we know that cos of a minus b equals cos of a cos of b plus sin of a sin of b, and we know that cos of a plus b equals cos of a cos of b minus sin of a sin of b. If we then add equations 1 and 2 together, we are going to get the following. So we are going to get cos of a minus b plus cos of a plus b. So let's just write that's equation 1, that's 2, and I'm taking 1 plus 2. And then on the right hand side, those two terms are going to cancel, and I'm only going to be left with cos of a cos of b plus cos of a cos of b. So in other words, it's just 2 times cos of a cos of b. So what that means is that if I have cos of a cos of b, it's just the same as a half cos of a minus b plus cos of a plus b. So that is how we went from here to here. Alright, so that was just a side note. Now what we want to do is we are going to look at the case firstly where m is not equal to n. Well, then we are going to work out the integral of both of them. So both of them, in other words, this part and this part. So what we are going to get then is the following. We are going to have a half. Then we have the integral of cos of m minus nx, which is going to be sin of m minus nx divided by m minus n. And then for the second term, it's going to be sin of m plus nx divided by m plus n. And we are integrating, that's supposed to be a minus, we are integrating between minus pi and pi, and we know that sin of any multiple of pi is going to be 0. So in other words, that is a multiple, going to be a multiple of pi when we substitute in our bounds, and that will also be a multiple of pi when we substitute in both bounds, whether we substitute in the top or the bottom. So that is going to give us 0. Then the next case we have to look at is when m equals n. So what we get in that case is we have the integral of from minus pi to pi. Then we have a half. Then we have, so m equals n. So our first term, that one there, is going to be cos of 0. So it's going to be 1. And then we have plus cos of m plus n multiplied by x dx. Then we work out our integral, so it's going to be a half multiplied by x, and that's between minus pi and pi, and then we have plus the integral of that, which is going to be sin of m plus n x over, and then we have, so we still have that half multiplied by that term divided by m plus n, and it is also between the bounds minus pi and pi. And once again, sin at any multiple of pi is 0. So at both the top and bottom bounds it will be 0. So this entire term is going to become 0. So that means that our final answer is going to be a half multiplied by pi minus a half multiplied by minus pi. So our answer is pi, and that is what we wanted to show.